You ever hear a really simple solution to a super complex problem and just think to yourself, nah, it can't be that easy? Well, guess what? You're usually right. Today, we are diving deep into why the most common and frankly the most honest answer in science is so often, it depends. We're going to uncover the hidden rules that govern how the world really works. So let's get into it. So let's start with the classic. This is a question you'd hear in pretty much any business meeting, right? You bring in a new super charismatic leader, you roll out a whole new style. Does it actually make the team better? The gut reaction is to look for a simple yes or no. But the real answer? Yeah, you guessed it. It's almost always way more complicated than that. The truth is, these one-size-fits-all answers are incredibly rare, especially when you're talking about something as messy and fascinating as human behavior. And you know what? This complication isn't a bug in the system, it's a feature. It's just how reality works.
Okay, so here's our game plan for getting to the bottom of this. We're going to start with the it depends problem itself, then we'll define exactly what an interaction is. From there, we'll look at the blurry magnifying glass that makes them so hard to find. And then we'll cover the best practices for actually spotting them and wrap it all up with why this kind of nuance is so incredibly important.
All right, first up, the it depends problem. You know, in science, a theory isn't considered mature just because it makes some big, bold claim. A really advanced theory is one that knows its own limits. It knows exactly where it works, where it breaks down, and most importantly, why. These limits are what we call boundary conditions, and finding them is the key to real understanding.
And look, this isn't some niche, obscure little concept we're talking about. In fact, research shows this idea is absolutely central to how things work. Pretty much every major theory about people and organizations involves these it depends factors. It's the rule, not the exception. The simple cause and effect story, that's usually just the movie trailer for a much, much more interesting film.
So let's move on and give this whole it depends thing its proper scientific name. In research, we call this an interaction effect. It's the formal way of describing those hidden conditions that can completely change a relationship we thought we had all figured out.
Okay, so what is it exactly? Well, an interaction effect happens when the link between two things, let's call them X and Y, isn't set in stone. Instead, it actually changes based on a third factor, which we'll call Z. This Z variable is the moderator. It literally moderates or changes the rules of the game between X and Y. It's the context that we so often miss. And this makes it crystal clear. On the left, you've got your simple theory. More job autonomy leads to higher job satisfaction. X leads to Y. Simple, clean, easy. But on the right, you have the more accurate interactive theory. Here, the link between autonomy and satisfaction depends on an employee's growth need strength. For someone who really loves to learn and be challenged, yeah, more autonomy is like rocket fuel for their job satisfaction. But for someone who prefers clear, direct instructions, that exact same autonomy might just be a huge source of stress. The effect just isn't universal.
So this is the big question. If these interaction effects are everywhere and they're so critical to understanding how things work, why don't we hear about them all the time? Why are we still getting all these simple one-size-fits-all headlines? Well, it's because finding them is unbelievably hard. It's kind of like trying to spot a tiny, tiny detail with a blurry magnifying glass.
You see, the main statistical tool that researchers use to hunt for these interactions has a pretty critical flaw. It often has low statistical power. You can think of it like a weak telescope. You might be pointing it at a beautiful, distant galaxy, but if the lens just isn't powerful enough, you're going to see nothing, and you'll wrongly conclude that nothing is there to see.
Let's quickly break down that term. Statistical power is simply the probability that your test will correctly find an effect that's really there. So if your study has low power, you are running a huge risk of what we call a type 2 error. That's basically failing to discover something that is genuinely true. You end up dismissing a great theory, not because it's wrong, but because your tool just wasn't sharp enough to see it.
So how big of a deal is this? Well, in a perfect best-case scenario, a researcher's power to find an interaction is about 0.81. That's an 81% chance of success. Pretty good, right? But just watch what happens when a totally common research issue pops up, like, say, a few participants drop out of the study. All of a sudden, the power plummets to 0.51. Your chance of making a huge discovery is now no better than a coin flip, all because of one tiny, totally realistic imperfection. Okay, so we've got a problem, a blurry magnifying glass. The good news is, researchers have developed a whole set of best practices to sharpen that focus. This is basically the toolkit for cleaning the lens and giving ourselves the absolute best chance to see these subtle but totally crucial interaction effects. It all starts way before any data is collected, in what we can call the blueprint phase. This is where researchers have to plan everything meticulously, calculating the right sample size to have enough power, and picking the most reliable, most precise measurement tools available. Good prep work is everything.
Now, once that blueprint is solid, the focus shifts to measurement. And this is where things get really, really sensitive. Any tiny error in measuring your variables doesn't just add up, it actually gets amplified when you're looking for an interaction. If your measurements are even a little bit fuzzy, that fuzziness multiplies, and this table shows you the shocking math behind it. So let's say the reliability of your measures for variable x and your moderator z are both 0.70. That's generally considered pretty decent in research. But when you combine them to actually test the interaction, the reliability of that new term absolutely plummet to just 0.49. That means over half of what you're measuring is just random noise. It's like trying to hear a whisper in the middle of a hurricane. So, with those precise measurements finally in hand, the last step is the analysis. A huge pitfall here is oversimplifying things. It's super tempting to just split people into high and low groups, but when you do that, you're throwing away a ton of crucial information and just killing your statistical power. Careful, detailed analysis is the only way to be sure you're seeing what's really there.
All right, let's zoom all the way back out. We've gone pretty deep into the statistical weeds, I know, but why does all of this painstaking work actually matter in the real world? What's the payoff? Well, it's about building way better theories, doing smarter science, and ultimately creating solutions that actually work. You see, finding these interactions helps us build better theories because it tells us when a theory works and for whom it works. It makes our science smarter because it stops us from throwing out a perfectly good idea that just happens to work only in specific contexts. And maybe most importantly, it leads to solutions that are actually effective. Knowing that a job enrichment program is only going to motivate employees who want that challenge, that saves a company a ton of time, money, and prevents a whole lot of frustration. And this really gets to the very heart of the scientific process. You can have the most brilliant, elegant theory in the world, but as this research reminds us, that theory simply cannot move forward without good, solid methods to test it. The two have to go hand in hand. So as we wrap up, I want to leave you with this question. Think about your own work, your own life. What's a piece of conventional wisdom, a simple truth that you've always kind of taken for granted? And now ask yourself, does it really hold true all the time? Or does its effect depend on something else? Because finding that something else is almost always where the real insight begins.